We're going to talk about it.
So here's where we're at today. So far, what we've been working up towards is we've been working on, guys, come on. This is kind of a big deal here. What we've been working our way towards was slowly being able to show that triangles are congruent. Now, the idea that we've been on is that up to this point, we've had to show that all of the corresponding parts, which means all of the sides and all of the angles, have to be congruent between two figures in order to say that they're the same. Well, what we start to do now with the congruent triangles is that we can start to whittle away a little bit of that. We don't have to use all of that information. For example, we're going to come up with, I think we'll go through 5 of them today, of just showing you different ways that you can state that triangles can be congruent. We don't have any progression stuff today. We're going to slowly build into the proof stuff, but I want you guys to be able to look at diagrams, be able to look at what you can mark within a diagram, and by getting that far, you're going to be able to do the proofs like that. Okay? This really is a very different approach to what I've done in the past, and first hour it flew, so I'm guessing it's going to be the same thing here. So here's what I want to do. There are different ways that we can show that triangles are congruent. One of the first ways is just to show this. Side, side, side. Now, what I mean by this is that I'm going to show you a diagram of what that would look like. So that way, if you see that diagram, you know that the triangles will be congruent to each other. We don't need long-winded definitions of if the 3 corresponding sides of one triangle are congruent to the 3 corresponding sides of the second, therefore the triangles are congruent. We don't need all that minutia. What we can do is just draw a picture. Do all those sides match up?
Yes.
Are the triangles congruent?
Yes.
Go to the next problem. That's what that's going to look like. That's what that looks like. Side, side, side. We'll get into all that. Okay? By showing that you have the 3 sides congruent to corresponding 3 sides to the other 3 sides, you can then say the triangles are congruent. That's one of the methods of what I call the alphabet soup, by just saying side, side, side.
Why is it called alphabet soup?
Because we're just using letters
Oh, okay.
instead of writing it all out.
Got it. Okay.
Another way is side, angle, side. Where do you think the angle is going to be placed? Does it have to be at the top? What do you think it's going to be between?
Sides.
Yeah. It's anytime you have a pair of sides that are congruent and what's called the included angle. The included angle is the angle in between the sides. If those two angle, or that angle is congruent to the other one, the triangles become congruent. Let me show you a picture. Is the angle between the 1 and the 2 tick marks?
Yeah.
Are those triangles congruent?
Yeah.
They don't. It doesn't have to be. The triangles don't have to be spun so that they're facing the exact same directions. As long as the parts themselves match up correctly, you can say the triangles are congruent. You don't see it that way a lot of times. A lot of times you will see it like this, where you've got just your 2 triangles with a side, an angle, and a side. As long as the way that the patterning of it is written out, you've got your side, an angle, and then a side, and it's the same tick marks on the other triangle, it works. And again, like you're saying, where all this alphabet soup come from, I'm just using letters. It is so much easier just to use the letters for this stuff, because there's a lot less thinking involved. Because if you get a diagram that looks like that, you know they're going to be congruent. Looking and working with pictures is so much easier than trying to write everything out. Okay. Side, angle, side. So we've had 2 sides and an included angle. Well, guess what? You can have 2 angles and an included side. angle, side angle. Two angles and the side between them. Two angles and a side between them. That's called angle, side angle. And again, as long as the side is between the pair of angles that are the same, it works. It'll always work. Angle. Another one that's really, really easy. Looks a lot like this one. Angle, angle, and side.
Is there an angle side side?
There is no ass in math. No, I'm serious. Say it with me. It's funny.
There is no ass.
In math. There's no ass in math. Say it. Come on. Get it out of your system.
There's no ass in math.
It feels good, doesn't it?
No ass in math.
There's no ass in math.
Are you for real? Dang it.
There's sides.
There is no side. Isn't side angle a backwards ass?
Yeah.
Yeah.
Sass.
So if there's no ass in math, there's no side angle in math. So it's kind of funny. I'm trying to get it out of your system because I know it's everybody goes, is there going to be an ASS? No, there's not. What's that?
What did you just say?
You can't make it.
Yep, you can't make an angle side out of you and me. Get it? Now you know where it came from. So angle, so we have angle, angle, side. Now, one thing that I will show you guys next week is that when we get through a little bit of this, I always like to use, Severino and I used this one program a couple of, 8 years ago we started using this one program, working with congruent triangles. And we'll do it, I think I have it set up for us to work on it on Monday. It's a virtual manipulative that we can actually create congruent triangles with specific side lengths. And there is, I shouldn't say that there is technically never an ass in math, because there is one scenario that it does occur. It is a very rare occurrence. For our purposes, for geometry proofs, there is never going to be an occurrence. I will say when you guys get to Algebra 2 next year, there's what we call the ambiguous case of the law of sines, and that does sometimes have an angle side reference to it. And also one of the very last thing I show you guys here, called hypotenuse leg, also kind of looks like angle side leg. The very last one then is called hypotenuse leg. HL. What kind of triangles have hypotenuse or hypotenuse? Nope. Nope. Yes, ma'am. Right triangles. Right triangles have hypotenuse because across from the right angle is always.
Not a right angle.
You're right. It's not a right angle. It's the hypotenuse. The hypotenuse is always opposite the right angle. It is always the longest side length in a right triangle. Okay? So what happens here is that you can have what's called hypotenuse leg if you have the corresponding, if you have a congruent hypotenuse, a right angle, and one of the corresponding legs. Now, in a right triangle, the other two parts that make up the other two sides that make up the right triangle are always called legs. It doesn't matter which one's which, but if the corresponding parts match up, where one leg is congruent to the other, that's what that looks like. Hypotenuse leg will only work with a right triangle sometimes. I don't want you to think that as soon as you see a right triangle, it's automatically hypotenuse leg. It's not always the case. Sometimes it'll be angle, side, angle, side, angle, side. It could be one of the others, okay? The hypotenuse leg, though, is the only time that you can get side, side angle, if you look at it, because it works within a right triangle. We just don't call it that because there's no ass in math, but there's a hypotenuse leg, okay?
It's so funny to hear teachers swear.
You bet your angle, side, side.
Oh, I get it. You're slow. I was just kidding, dude.
That's
As
scary.
he's covering it up. So what happens here is that you've got 5 different methods to be able to show that triangles are congruent. And what we're going to do today is go through a couple of very simple diagrams. And I want to show you guys the way that it could look. I want you guys to be able to look at what's called a reflexive side to be able to depict what way you can show that things are congruent. Yes, sir.
Isn't SAS, ASS? No, because they're in between each other. I was thinking, couldn't you change side angle side to angle side side?
You can't, because what happens here is for this to work, it has to be the angle in between the two sides. So if this angle was not between the two sides, then it would be side-side angle, or side-side angle going the other direction. And therefore, it's possible that it would not work.
They have to all be in our.
Correct. And that's why we have them in between here, because it tells you what's included. Here the angle is included, here's the side is, here it's 2 angle, and then a side.
Gotcha.
I was just gonna.
That's how that goes. Questions on those 5?
Yes, he is forever going.
Mr. Murphy, can I come back
What?
Seriously, you guys all gotta go to lunch here soon. Whatever. I'm throwing that thing out.
I have an 8 hour. I have a 6 hour. I have a 10 hour.
I have a 10 hour.
You guys have any idea how gross
I
that
have
thing
10 power.
is? That thing goes to the bathroom all day long. Ooh, the fish thing. It's the grossest thing in the world.
What? Wait, a fish thing?
Mr. Murphy,
I wouldn't touch that thing.
What is it?
Mr. Murphy, you know like the Amazon Echo thing where?
Yeah.
Have you seen the one where like they put the thing inside the fish, inside the talking fish?
No,
So then they turn the fish into like the Echo.
that's awesome. That's great. That's very good. It needs a extension.
Mr. Murphy.
What? No, I'm doing examples. Oh, you did?
Yeah, I got really close to double deckers too.
That's cool.
I'll show you photos later. I don't like the
Is it favorite? Oh yeah, Albrecht would always do that with us. So I didn't have to have emergencies.
So, everybody get one? Did you guys all get one?
No, we did not.
Do we run out of them up there?
Yeah, right now.
We don't need them. Us 4 don't need them.
Alright, so here's what we got. Ladies and gentlemen, I don't have that much more material, but I do want to make sure we get this down. So, here's what happens. What I want you guys to see here is I want to look at diagrams and pictures and try to figure out if there's a possible way to show that triangles are congruent. And if so, what other things do I have to mark within the diagram? Now, one of the things that's going to happen quite often is, for example, a number 1 here, and I want you guys to take your progression sheet. And I want to use.
Did we ever get them?
Did I give all those back?
Yeah.
Oh, really?
I don't think so.
You got yours.
Which where did you get your progression sheet?
He's back.
You know what? I think there was a handful of you guys who still gone from on Thursday.
Okay, well this one's fancy.
That movie
No,
things.
they won't. Yeah. That's okay. Yeah. Now you see what I'm talking about. You did? I don't think I
Yeah,
got
there's
it
a
back.
hand. Let me do this real quick, because there are a handful here I forgot about. Often within proof stuff is what we call a shared side. whenever you have what's called an overlap shared side, it's basically called a reflexive side. So what I want you to do is in one of your squares, take up about half the space and say, look for a reflexive side. Basically, that is a shared side. Now, the reason that I want you to say that is because this is something that shows up time and time and time again in a diagram that you're allowed to mark and you're allowed to say that is congruent for your proofs. Because aren't you congruent to yourself? So if, for example, this was A, B, C, and D, isn't AD congruent to AD? So what we would do is we could mark the diagram as a reflexive side and put tick marks in, which means now what do I have? Side, angle, side. That's what we do. Does that make sense? So now, if I look at the next one, what am I going to do?
Do the same.
Same thing. What do you get?
Side, side, side.
Side, side, side. And then the next one, what do you have?
Angle, angle, side.
Angle, angle, side. All right, do the next 6. We'll check them in a minute.
So like this arm.
Like 4 through 9, you mean?
Yeah. Do those real quick, and we'll check them in like 2 minutes.
My leg.
So you just
There
add
are
tick marks?
many different ways to look for these things. When you're looking at your, like I said, when you're going through these things, it's the idea of looking at the diagram, trying to decipher whether or not you have some sort of overlap. If you're shown that you have an overlap, like again here in number 4, see how often that happens? You mark it right away. So you're going to get in the habit of marking that, oh, I've got this overlap shared side, I've got this reflexive side. Now, according to my diagram, what do I have? I have angle, side, angle. Angle, side, angle. It matches up. That fast. I go to the next one. Is there an overlapped side?
Yeah.
A reflexive side? I mark it. Well, what do you have?
Side, angle, side.
Side, angle, side. Very good. Side, angle, side. You start with one side, go to the angle, go to the other side. Okay? In 6, there's a bunch of ways of doing it.
I put side.
There is definitely hypotenuse leg right away because you've got the hypotenuse across from the right angles and you have a leg. What's another one?
Side, angle, side.
Side, side,
Side, angle, side.
You have side, side, side because of the reflexive part in the middle. And then what's the other one? You can also say side, angle, side.
So I wrote.
There's 3 of them in this case. Okay, there are 3 of them in this case. Actually, later on, number 6. Number 6, if you look at the large triangle, the large triangle is an isosceles triangle. Isosceles triangles have so many different little bits and pieces you can draw and talk about. That is the altitude of an isosceles triangle, which means it's the perpendicular bisector of a side, which means it's the angle bisector at the top. There's a lot of bits of things. We're not there yet. 7, what do you have?
Side, angle, side.
Angle, side.
Hold on. Wait. So,
I got
wait.
Side, angle, side.
So where is this side, angle, side?
Oh, for 7? There's a side, angle,
Side.
angle.
Oh, angle.
It's hypotenuse.
Hey, this is another hypotenuse leg. Correct. This is a hypotenuse leg. But, well, don't cross anything out. What do I know about these 2 angles? They're vertical, aren't they? Aren't those 2 angles congruent to each other?
Yes.
So doesn't that mean I have angle, side, angle?
Oh, that's not what I put in.
Doesn't it also mean I have side, angle, side?
Oh, yeah.
But here's the thing, you have to have that vertical angle bit to make that show. Now, on your progression sheets, guys, on your progression sheets, you should have a square that references look for vertical angles. Anytime you see a triangle showing up that look like a bow tie, make sure you write down vertical angles right away because you know that they're congruent. It's a very simple step. So the idea that we're working ahead on just looking at diagrams, building out of diagrams, it's just going to make everything easier later. Because when you're starting to be given information, you're going to have to go to the diagram anyway to mark it. Okay? What about 8? What do they have in common?
Sides.
Angle, angle, side.
Whoa.
Side. Oh, wait.
They have this
I
in-
think we're on the next one.
Oh, were you ahead of
I
it?
said
All
no.
right. And number 8, they have an angle side angle because they've got that shared reflexive side again. Okay. Now, when I go to that last one, then on 9, that's a shared side there. It's going to be side, side, side. Oops. It's going to be side, side, side. Okay.
Yeah, because it keeps going up. Oh, man.
That's weird. I rarely drop, like ever. I never drop. That's it.
Was that sarcasm?
No, seriously. I'm always doing this, and I'm rarely ever. Leah just said I've only dropped it twice all year, so
Wow.
I do that all the time.
Okay, let's just work on that.
Okay.
We have homework
Of course we do. I'm glad you asked. Let me give you the sheet. It's the same stuff, guys. Same thing.
Mr. Murphy, here.
Can we please have homework tonight?
What?
I know what's
Hey, I like that shirt. Kevin. I like that shirt. Yes, I do.
Hey guys, it's the same stuff. It's the exact same stuff.
If I get it done right now.
Stop, you're going to
Does your class just like too? Yeah.
I don't know because I don't have the other triangle. And you don't know the hypotenuse can be across from the right angle. You can't do it
Why are they on there then?
because it got run off. There.
Oh, that's all I
So real fast. What I want you guys to see here, I want you guys to look down at number 11 real quick. Number 11 is the first example that you've had that has parallel lines. So when you have parallel lines, according to your progression sheet, it always said to look for angle pair relationships. Well, what I would do is I'm looking right now, I've got this one, and here's my transversal. Which means that I have corresponding angles here and here. You agree?
Mm-hmm.
If I tilt my head sideways, I have parallel lines here and here. And where is my other set of corresponding angles? And you get what? Okay. What's going to happen sometimes with parallels are the ones that take the longest to get used to because you got to redraw some of the diagrams. The rest of this stuff is going to be really fast. Now, there are a couple on here that are not possible. Be careful when you walk through those. You can only have these 5 possibles. Remember, is there ask in math?
No ass in math.
There's no ass.
For our purposes, is there?
No.
Oh, yeah, but we're recording the whole hour.
What numbers are we doing?
Yes, sir. Yeah, we don't.